We got a tough one to deal with. Let's do it. So what we are looking at is an improper integral with infinite integration limits, plural. So we're going to have two limits. We're going to have one that goes towards negative infinity, that'll be A, and one that goes towards positive infinity, and that will be B. Let's take a moment though and look ahead and realize that we're going to have to wrong word. Well, actually that's going to happen in a minute. We're going to have to figure out how to integrate this thing. So let's just sort of cross that bridge before we really even get there. We're not going to cross that bridge when we get to it. We're going to cross that bridge now. And here's how. This is not it. Don't write this down, by the way. This is going to get us nowhere. U is equal to 1 plus e to the 2x. This is our first gut reaction, right? So du would equal 1 goes away. Chain rule 2e to the 2x. Let's chain this mug. And there we go. I don't want 2e to the 2x. I want 1e to the 2x. So I'm going to divide by 2. And that gives me e to the 2x dx. That gives me 1/2. And I hope you see the problem. The problem is this. I want e to the x. I don't want e to the 2x. How are you going to get that 2 out? You know, you can divide by 2 to get rid of that guy, but what are you going to do about him? Don't know. Okay, I'm going to rewrite this. It's going to be kind of an elaborate rewriting with a brand new ink pen, brand new marker. I don't know why I'm bragging about. Look at the school supplies I got. Here goes. Isn't that wonderful? So much darker and easier to read. This is going to be A, so we're going to have the limit as A approaches negative infinity of an integral from A to, okay, we can't go to infinity, right? And what we're going to have to do is break this up into two separate pieces. We're going to figure one of them out that goes from negative infinity to somewhere, and then that somewhere to infinity. I think the most logical place to stop this is at 0. That's going to be the best thing to do. And this is actually on the front of your notes. It talks about how you can split things up into separate pieces. And so we're going to have e to the x, and then this one is going to be 1 plus e to the 2x. I'm looking ahead to how this will integrate. I didn't finish the conversation here before I got carried away. You know, when we were going to cross the bridge before we got there, never crossed the bridge. Now we're starting to get there. So I'm going to call that e to the x, but I'm going to square it. And it's totally okay to do that because of where this is going, okay? This is one of those circumstances where you put your marker away and you walk back over here to the bridge that you didn't have to cross at the time, and you pull out an old friend of a formula and you say, maybe, just maybe, it's structured like this. Maybe. Of course, we won't need to see because it's a definite integral. But maybe it's that. And it is. It is. A is 1. U squared is e to the 2x. Let's experiment with that. If e to the 2x is u squared, then if I square root this, I'm basically taking half of my exponent, so it's e to the x. And then the derivative of that is e to the x dx. Everything I need is right there. I'm going to hold this thought for a minute because we're going to come back to this, not the C part, but we're going to come back, in just a minute to it. Now, which one was the good marker? We're about to find out. Okay, we actually haven't finished going all the way to infinity. Apparently infinity is this way. Come towards infinity. Step into the light. Oh, there's the good marker. And we're going to have another limit, and that limit is where b approaches infinity, and it's going to go from 0 to b of, same thing, e to the x, 1 plus e to the x squared dx. Woo, I forgot my dx over here. Tragic. There we go. All right, that was very tragic. I might get fired for that. Again, I'm making this look like this format, so it's 1 squared plus e to the x squared. We kind of worked through that a second ago. So we're going to take the antiderivative of both of these integrals, the same antiderivative, just different integration limits. So let's keep going. Limit as a approaches negative infinity of, okay, something from a to 0 plus. We'll deal with it later. Sometimes I skip things if I want to just keep talking about something else. I'll cross bridges before I have to. Limit as b approaches infinity of that same thing, and it's going to go from 0 to b. So it's going to get a little tricky. So we are ready to integrate. Get this rolling chair out of my way before I kick it again. And as I do, again, I'm identifying the individual pieces, and A is 1, and U is e to the x, not e to the 2x, because e to the 2x is really e to the x squared, because you'd multiply those exponents, right? Yeah, so e to the x squared would be e to the 2x. And so I really have 1 over 1, so don't write it, arctan of e to the x over 1. So it's really just arctan of e to the x, and same thing here, arctan of e to the x. Cool. All right, we're ready to plug some numbers in. We're going to erase the stuff in blue, and then we will start finding some limits using the fundamental theorem of calculus. So we have the limit as a approaches negative infinity of arctan of e to the 0, we'll cross that bridge in a minute, minus arctan of e to the a, that is e to the negative infinity from our theoretical limit point of view, and then plus the limit as b approaches infinity of arctan of e to the b minus arctan of e to the 0. And let's figure this out. Okay. First of all, first of all, like I'm screaming into the microphone. First of all, a approaches negative infinity. This limit only applies to that term, and this b only applies to that term, but we'll leave them hanging around. So I'm going to go ahead and figure out arctan of e to the 0. Sorry, my mind went blank because I was thinking ahead. Arctan of e to the 0. Let's come over here on the side and talk about it. Arctan e to the 0. Well, e to the 0 is 1, so I really want arctan of 1. And so then, again, arctan is a question, and the question is, at what radian value will my tangent be 1? Unit circle. Tangent is 1 here. Where's that? Well, there, 45 degrees, but we don't play with degrees in this class. This would be pi over 4. So pi over 4. Looks good to me. So pi over 4 minus. Okay. Whew, now it's going to get fun. I need the limit as a approaches negative infinity for the arctan of e to the a. Hold that thought. If I had e to the negative infinity, theoretical work is coming over here. That was practical, but here's theoretical. E to the negative infinity, I really want arctan of that. Okay, so it's all theoretical here. So don't put this in a free response question and expect it to be graded and be like, oh, well, we have negative infinity as an exponent. That's why we have limits. This is just me thinking through stuff. This is 1 over e to the infinity. Well, e to the infinity is ridiculously large. That's infinity, which gives me 1 over huge, which is 0 for practical purposes. So the arctan of 0. What is the arctan of 0? Let's rephrase that. At what radian measurement is tangent equal to 0? That would be here, 0. That's it. Okay? Plus. Let's keep going. Arctan of e to the b. B is approaching infinity. So more theoretical work over on the side here. So I really have arctan of e to the infinity, which is really arctan of infinity. So at what radian measurement is tangent infinity? It's a pretty good circle. Why, thank you. It's right there. That's where it's undefined. We had crossed that bridge crossing a lot of bridges. We had talked about that in a different lesson, a different video. Same lesson, different video. So we are approaching infinity at pi over 2. So pi over 2 minus. Okay? Well, let's see. Minus arctan of e to the 0. Oh, arctan of e to the 0, we found it out already. It was pi over 4. And I would like to think that all this math will flush out quite nicely, and it does. Pi over 2. That's it. Isn't that nice? I think so too.